Today we'll be covering lesson 7.3, using similar right triangles. And we're using properties of similar right triangles today. So first theorem is a big one. We've already proved this in the past, back in chapter 6 with similar triangles, that if the altitude is drawn to the hypotenuse of a right triangle, then the triangles formed are similar to the original triangle and each other. Two triangles that are similar to a different triangle are all going to be similar to each other. Transitive property of similar triangles. But we've got triangle CBD similar to triangle ABC, triangle ACD similar to ABC. Again, these are all pretty short proofs that we did in the past. And again, mainly relied on saying right angles are congruent to each other in two steps. Given perpendicular, and then they share an angle. Oh, angle A and angle A, they're the same. Angle B and angle B, they're the same after that right angle. And the only one that took a little bit longer was proving between the two when they did not share an angle. We could still prove that DCB is congruent to DAC. Right? So we're going to identify similar triangles, then solve. So the three triangles that are similar to triangle, three letters, similar triangle, three letters. And again, I'd recommend starting with two that you know are similar. So in general, I'm going to start with the first letter is going to be the right angle. So for the large triangle, right, we're going to say angle M is our right angle there. And then we're going to use J, MJF. The next triangle, if I do triangle K here on the inside, triangle KJM, I'm going to do K first, we did the right angle. We just did J, so J has to be the second letter in M, right? J has to be second by our reflexive property. And now the last one won't use J, so the angle that will equal J is going to be this angle KML. So K was the right angle, M is that J equivalent and L. The other way to think about it is in the first one, angle L needs to be in the same place as the last one. So angle L was last, and KML, angle L needs to be last. So those need to be equal in terms of orders. So next we're going to solve. You can use these letters to help you solve. In general, I would say it looks like this is the long leg, right? So say in that small triangle, we say long leg to hypotenuse equals 12, long leg to hypotenuse of the large triangle, 13, and we get, cross multiply, 13x equals 5 times 12, 60, divided by 13, and so x is 60/13, which is on the calculator, 60 divided by 13, maybe a little less than 5, 4.62. I rounded up. Next one, same idea, with these triangles down here, CHG, HGF, and EGF. So again, I'm going to do large triangle first. We'll start with the right angle, then angle F and E. The next one, I'm going to use this triangle here that has angle F, so I can guarantee H is my right angle. F is used again in the same spot, and then G. And then the last one, I'll make sure E is in the last spot to match the first. And so then our right angle again is H, and the other letter in that triangle is G. So GFE, similar to triangle HFG, similar to triangle HGE. And again, we've kind of got, we'll say x to 3, so it's like long leg to hypotenuse equals, for long leg of the bigger triangle, hypotenuse 5. So we get 5x equals 12, and x is going to be 12/5, which is about 2.4. Depend on the question, some may ask for decimals. If they do, round to their decimal. If not, you can leave it a fraction point. If it's a word problem, I recommend simplifying. As in the next one, we've got a diagram that shows a pool that is 48 inches deep, and then we have a triangle similar that we've been dealing with today for the deep end of the pool that apparently is about 165 inches long. The hypotenuse of the big triangle there, in here. And we've got it broken down into a couple triangles, so we need this H, again, the altitude there, and we're going to use the 152, the 64, and 165 to help us get that. So in this example, I'm going to do it again, height as the long leg of this right triangle here, so H over 64 is going to equal the long leg 152 to 165. Now this one's not as nice number, so on the calculator, again, cross multiply and divide. 165h equals 64 times 152. And when we divide these on the calculator, I got that h was about 58.96 inches. Again, rounded. Now, h is not our answer. H is just how deep the deep end goes beyond our part, right? H is just from the deep, 4 feet deep already to the bottom of the pool. So we need to add another 48 inches to that, and we'll get 106.96 inches deep. That's how deep the pool is. Next, proportion involving geometric mean. Now, a reminder about geometric mean, again, was if x is the geometric mean, right, we had x squared equals ab, or the proportion was typically a over x equals x over b, x being in the means position, where a and b are in the extreme positions. Now, these triangles are not always in this orientation, so beware. Okay, but here is the pattern, right? And again, the purpose is if we know two sides, we can solve for the third, whereas in the previous ones we were doing, we needed 3. So what happened is, say we're solving for CB right here, the red line. We need to know DA and DB, not the whole AB, because the proportion is going to be BD over CD equals CD over AD. Now, if we put BD and AD, it's still the same answer. Now, notice, those are the two pieces that touch the endpoint of that red line. The next one, erasing that, trying again. How about for the green one? Which one do we need? This green line here. We need the two segments that connect it. So this segment here, DA we need, which again, I'm doing this one on the far right. So DA, and we need the whole piece, B to A, or AB. So AB to CA, or AC, equals AC to AD. Last one, same idea. What are the two segments that connect in touch CB? Right, the endpoint. Which ones have B? We've got DB and AB. And that's this one right here. AB to CB equals CB to DB. That is the best way to remember it that I found in practice. So here are those. It shows you the two proportions. Okay. And given the triangle situation, and in a right triangle, the altitude from the right angle to the hypotenuse divided into two segments, we already know those are similar triangles from 7-5. Right? Then it says we can do that geometric mean rule. Same thing over here and over here. Okay. Now, solving for y. Notice we only have 3 pieces. Orientation is different. Last time our kind of red angles in the picture was on top. So what are the two pieces that connect? They won't always be that y is our geometric mean. So pay attention. We've got 3 which connects to r, and we've got 9 which connects to r. What if they gave us PS instead? We could add them together to get r. So this is 3 over y equals y over 9. Y squared is 27. And then when we simplify, we can get 3 square root of 3. Square root of 9 times square root of 27 is, sorry, square root of 9 times square root of 3 is 27. Pardon me, square root of 9 is 3. Or if it asks you to simplify on the calculator, square root of 27 is a little more than 5. On my calculator, I got 5.20 rounded up, from 5.196. Okay. Next, a little bit hard to see in the diagram, but we have a person using a right angle to help measure the angle, the height of the wall when he doesn't, have that information. So we've got this bottom piece 5. We've got that the person is 8.5 feet from the wall, and then we need to find W. So again, 8.5 is part of the geometric mean. We have this piece, we've got this piece, and then we need W, right? So it's the setup is going to be, we'll write in yellow for this, 5 over 8.5 is going to equal to 8.5 to W. Again, you had to step a certain way back so that looking down the piece of paper will look at the corner, and looking up the right angle piece of paper will lead them to the top corner. We have 5W equals 8.5 squared. So when you divide by 8.5, sorry, trying to divide by 5 on both sides, we get 14.45. Again, that looks to be in feet, so feet plus the 5 feet, it asks for the height of the wall, 19.45 feet. Next, we got some proofs coming out. Okay, prove theorem 7.6 by showing BD over CD equals CD over AD. Now, in the past, we proved similar to this already. The nice part is we are allowed to use theorem 7.5. Now, normally I have it numbered for you. This is 3 steps because we don't need to prove similar. Why not? If we scroll back up to the first slide we did, the first slide had as a theorem, these triangles are similar. We have that situation, so we can go ahead and use that, right? So first, it's not really showing us, but basically we're given this triangle situation, right? Given, we're just going to say the diagram for now, but given diagram, we've got perpendicular and all that information in there for altitudes. So from the diagram, we're just straight able to say triangle DBC is similar to triangle DCA. And again, why do we need those two? We need the triangle that has those two pieces, so BD and CD. So this triangle here, hard to see in purple, sorry. It's still hard to see in blue. There we go. That triangle, symbol, and we need CD to AD, which is this triangle. So yellow and kind of a maroon pinkish color triangle. So those are the ones we needed congruent. D was our right angle, so DBC. And then the other one is going to be DCA. That is by theorem 7.5. You can try to write it, but it's kind of one that we're not going to use much. We're just going to use for these theorems. And then next, we just need to say, well, by definition of similar triangles, right, we've got BD to CD equals CD to AD. So a lot shorter than proofs of the past of proving theorem. One last set of proofs is proof theorem 7.7 showing the same thing. So again, showing back as proof, you can write it down, doing the same exact 3 steps. The only difference is there's 2 separate proofs, one for each piece, okay? Because there's 2 different sets of triangles we proved. So we'll just choose one. So in this case, the left side, if again I draw those segments, AB to CB, we're doing the whole triangle compared to CBDB, which is the small. So I would say whole to small, and this second one would go from medium to the whole, right? M to W, medium to whole. So we're just going to do this one on the left. Same exact steps again. Diagram is what's our given. Theorem 7.5 gives us a similar triangle we need. And at this point, we're not too worried about those. So triangle, C was our right angle, so triangle CBA. So we can both use triangle, the right angle and triangle angle C, and BDBC. So repeat, triangle CBA, similar triangle DBC, given from theorem 7.5, in your definition of similar triangle or similar polygon, however you want to say it, says our sides are proportional, and AB to CD equals CB to DB. That wraps up today's lesson. The assignment is listed right there.